3ds Scarlet is our brand new standalone tool dedicated exclusively to laser scan management and comes bundled with the full version of 3ds Zephyr at no additional cost. In this video tutorial, we will dive deep into the functionality of 3ds Scarlet for laser scan registration. You can open 3ds Scarlet through the 3ds Zephyr interface by either clicking the 3ds Scarlet icon in the toolbar or alternatively through the Utilities menu. Otherwise, you can launch 3ds Scarlet directly from your Windows menu as it is a standalone software application. Once you open 3ds Scarlet, you will find that the UI resembles the familiar and user-friendly interface of 3ds Zephyr. This software includes 3 different manual registration methods. A new photogrammetry-based algorithm able to perform automatic scan registration, the transform using tools function that allows you to roto-translate your scans using the Gizmo, and finally, manual alignment using control point constraints placed on the laser scans and their bubble views. Along with these functions, you can additionally leverage the fine alignment optimization, namely the Icp and Multi-Icp algorithms. Scan files can be imported through the creation of a new project, where you additionally specify the project's path, its name, and the accuracy threshold desired. The scans are listed in groups on the left-hand side of the UI under the Project tab and must be selected in order to convert them and visualize them in 3D space. Every scan can either be visualized with its RGB data or by uniform coloring. To do this, simply select your scans, right-click, and enable the uniform coloring option. In the viewport, you can interact with your scans by rotating them, zooming in and out, and panning with the mouse wheel. You can choose between 3 different view modes. The free look mode that lets you move in your scene using the mouse and the WASD keys. The orbit mode that allows you to rotate and zoom in and out around a fixed point in the scene using the mouse. And finally, the pivot mode, similar to the orbit mode, however, movement is around a picked point of interest. Automatic registration and multi-ICP. Once you have imported your yet-to-be-aligned scans, the first registration method offered by 3ds Scarlet is automatic registration, a tool which exploits the photogrammetry-based algorithm developed by 3D Flow, which is unique to 3ds Scarlet. Click on the automatic registration icon to start the procedure. A dedicated wizard will appear, and through this you can select the groups of scans on which the automatic registration will apply to. In the settings page, you can set your inlier threshold along with the kind of matching you desire. You can also set the matching type to either very fast or fast in order to speed up the processing using approximate clustering. You can eventually set it to accurate if the scans have not been aligned correctly. Make sure to use the automatic registration tool only with scans that have embedded RGB color information, as seen here in this example. After computation, all the registered scans will be listed as a single group. It's not mandatory, but strongly suggested that you run the Multi-Icp Optimization after automatic registration to further improve your scan alignment. Simply click on the Multi-Icp icon in the 3ds Scarlet interface, select the group of registered scans in the wizard, and click Next. Define the pairings of scans that will be taken into account by the algorithm. Finally, set the ICP parameters to go ahead with the registration. Once you're okay with the settings, simply click Finish. At the end of the Multi-Icp optimization, you will see a histogram with the residuals, namely the medium distance and the variance values. Note that you can always set the desired inlier threshold that was previously set when you started your project. registration via 3D Gizmo and Multi-Icp. The second registration method available in 3ds Scarlet centers around the 3D Gizmo, a tool that allows you to manually translate and rotate pairings of your scans. Click on the Transform Using Tools button and a new wizard will pop up, where you can select your reference scan and moving scan. Once you have selected the desired scans, the Gizmo will automatically be enabled so that you can rotate and translate your moving scan towards the fixed one. For efficiency, there are 4 icons in the bottom panel through which you can customize the view of your elements within the workspace. You can also precisely adjust the translation and rotation of a scan using the mouse wheel over the corresponding value. Click the Manual Alignment button once you've finished the first roto translation step using the Gizmo. This will lead you directly to the Fine Alignment panel where you can access the parameters of the ICP for the cloud-to-cloud registration. The values shown here have already been adapted to the accuracy threshold that you chose when you created your project, but you can always adjust them to suit your needs. The most important parameters to consider are the minimum and maximum inlier threshold values. These determine the search distance range between corresponding points across multiple input scans. It's recommended to lower the minimum inlier threshold if your previous alignment accuracy was high, and increase it if your previous alignment wasn't very accurate. You should lower the maximum inlier threshold if you were satisfied with the accuracy of the previous alignment, but increase it if your previous alignment wasn't very accurate. By clicking Fine Alignment, 3ds Scarlet will start the ICP registration. At the end of the computation, the histogram will be presented with the residuals in the Epilogue panel. When you click Register, your moving scan will be included in the same group as the reference scan. Now, simply redo the process with the Gizmo for all the scans that are still not registered. Remember, you can always select the best scan to use as a reference object from the group of already registered scans to better help you with manual alignment. After the manual alignment has been completed, the laser scans are listed in a single group as we've already seen. You can now decide if you want to go ahead with the Multi-Icp Optimization. This last step is not mandatory if you're already satisfied with the level of accuracy reached during the fine alignment of your scans. Control point registration. The third method for manual alignment is through control points. This procedure allows you to perform a roto translation of your scans by manually marking overlapping features between scans. This is a great registration method for both architecture and urban subjects such as building facades, which tend to have distinct and recognizable features. Click on Register Using Constraints to start picking control points. Firstly, select the scan you'll be using as a reference, and then select the moving scan. By default, the tripod view is enabled and displays the laser scan's bubble view from the inside. Usually this view is the best choice as it's easier for point picking, but you are free to select the view mode you find the most comfortable to work with. Place at least 3 control points that have corresponding positions across both the reference and moving scan. Remember that this doesn't have to be super accurate because we are still in the manual alignment phase. Once you're done, click the Course Alignment button to reveal the Fine Alignment panel with your ICP settings. Then, simply click the Fine Alignment button to register the first pairing of scans. Redo the process for all the remaining yet to be aligned scans until they are all listed under a single group. In addition to the most common laser scan formats, 3ds Scarlet can read and import the native laser scan formats for Faro, Regal, ZNF, Dot Product, and StoneX instruments. In order to read the native formats, you must download the latest 3ds Scarlet and 3ds Zephyr plugins available on our website through the link in the description below.